2014 Relative Velocity Question 2 Part B. At noon, ship B is 300 kilometers south of ship A. Okay, we'll start with a drawing here. Ship B is 300 kilometers south of ship A. So we have ship A and ship B, and we have 300 kilometers. Ship A is traveling southwest, so 45 degrees, at 24 root 2 kilometers an hour. So if we draw our x-axis across like this, ship A is going southwest. So it's going down this way. It'll be a 45-degree angle in there and in there. So that's the direction of ship A, and ship A is traveling at 24 root 2 kilometers an hour. What's ship B doing? Ship B is traveling due west at 31 kilometers an hour. So ship B is going in this direction, due west at 31 kilometers an hour. And we're asked to find, well, we write them out as vectors, but what are we asked to find here? Find the magnitude and direction of the velocity of B relative to A. The velocity of B relative to A, which all of you guys know is the velocity of B minus the velocity of A. So let's write these vectors out. The velocity of B, easy enough, it's just going in the minus I direction, so it's just going minus 31 in the I direction. It's not going anywhere in the J direction. A, however, we have an angle and we have a speed. So the speed, well, in this case, the angle actually doesn't matter here. But if we look at our I vector is down here, it's opposite 45. So if that was an angle other than 45, it would matter here. But don't get your cos and sine mixed up. So we're actually using the sine of 45 here to get my I vector, and the cos because it's adjacent along here. Sorry, along here to the angle. I'm using the wrong line to get my J vector along where it says 300 here. So we have, and what direction is it going? Minus, minus. So we have minus 24 root 2 sine 45 in the I direction, minus 24 root 2 cos 45 in the J direction. And sine of 45 is 1 over root 2. So we're going to get the root 2's to cancel, so we're just going to end up with minus 24 in the I direction, minus 24 in the J direction for the velocity of A. So the velocity of B relative to A is going to be the velocity of B. What have we got? We've minus 31, and then I have the minus 24. So it's going to be minus 31 plus 24 in the I direction, and in the J direction it's going to be 0J minus 24 in the J direction, so plus 24 in the J direction. So the velocity of B relative to A is going to be minus 7 in the I direction, plus 24 in the J direction. We are asked for the magnitude and the direction. So the magnitude of the velocity of B relative to A, can you see that this works out evenly? It's going to be 25. The square root of 7 squared plus 24 squared, 25 kilometers an hour. And the direction, the inverse tan of 24 over 7 will give me the angle we'll call theta. And the inverse tan of 24 over 7 is 73.7 degrees. Now let's have a look at what direction it's in. We have a minus plus, and minus plus is this way, so it's north of west. So that's part A complete, I think, is this or no? No, another part. If the ships can exchange signals for 2.8 hours, find the value of D. And we're told up above, A and B can exchange signals when they are within D kilometers of each other. Okay, let's do a diagram here. Let's just keep some of the information. So we have A and B, 300 kilometers. So B is going in this direction technically, but the velocity of B relative to A was that way there, wasn't it? Minus 7 plus 24. So this is going to be the shortest distance between them. We'll call it X. So we can definitely get that. Well, let's get that first, or will we map out how to do that? If we get X, well, let's work out how to get X first. This is actually the angle that we have. The direction that it's going in is measured against the X-axis, and we got that to be 73.7. So this one in here is 90 minus 73.7. So that's 90 minus 73, which is 17, so 16.3. So we want the opposite to this angle here. And we have the hypotenuse here. I'll just call it H, hypotenuse, 300. So we can say that we're using sine opposite on hypotenuse. So the sine of the angle 16.3 is equal to opposite over hypotenuse. So 300 sine 16.3 is that shortest distance between them. So they haven't asked us that, but we do need to get it, I think, to work our way around to finding the distance that we're going to be looking for now in a minute. And that works out to be 83.999 or 9989, so 84, we'll call that 84 kilometers. So just go to a new diagram now. So we have this and this. We have B relative to A. We have our shortest distance of 84. So what are we looking for in this? We're looking for this time along it. This is the distance between them, say, when they're in range. And we're told it's 2.8 hours in the question. So they can exchange signals for 2.8 hours, find the value of D, and D when they're within D kilometers of each other. Okay, so this is D, this red line is D. They can exchange signals within this range here. So we have our 84. What do we not have? We don't have anything else within that triangle other than a right angle, and this red line I'm creating here is our 84. So what can we say? What else have we got? Well, we have B relative to A. If we write that down, the velocity, we have the magnitude of the velocity of B relative to A, which was the square root of 7 squared plus 24 squared, which was 25 kilometers an hour, which was here. So that's the speed it's going at, 25 kilometers an hour. We can also say that this section here and this section here are half of the 2.8 hours. So they're about 1.4 hours. So you can see here, that's time, that's speed, distance, speed, time, triangle, distance is equal to speed by time. So this distance we'll be able to get in here now. That distance, I'll call it big D, is equal to the speed, 25, by the time of 1.4 hours. So that's 25, and 40% of 25 is just 10, so that's 35 kilometers. So now I have another diagram. I have this right angle triangle in here. I'll draw it in the same type of way. We've got our right angle. Our shortest distance was 84. We worked out the bottom here to be 35. So this distance D is equal to the square root. And you're glad you learned Pythagoras now, because D is the square root of the two straight sides squared and added together. So you get D to B. You get exactly 91 on my calculator, and I hope you do on yours too. So 2014, la-di-da.